So there is the go live. Hello and good morning, everyone. Good morning, Jemsen. Good morning, Tobias. Great to have you guys back here in the next episode of our gas sampling webinar. And I'm very excited about this one because it's a special one. But first of all, Jemsen, how's everything? Are we online? Are you checking in parallel?
Yes, we are on live.
Okay, that's great. That's great. Because we made some improvements. I found out I was having another webinar for special process analytical background, and we found out that we always made some mistakes when we set up the webinars at the last time. So I think this time it should be easier. Welcome everyone. And let me shortly introduce my dear colleagues here. I'm starting with a person who is actually some 1,000 kilometers away. Jemsen, very good afternoon to Singapore.
Yeah, it's hot and humid. Thank you, Jörg.
As usual.
As usual, it's hot, hotter, or hottest.
Yeah, this is the thing. Very true. But Jemsen, let me say I'm super happy that you are back, and maybe you can show around, or you can at least show our new logo also arrived in far away Singapore. This is very good to see. So you managed to replace the sticker. The stick plus?
Yeah. You know.
You're an expert. Jemsen, you are an expert. It
Yeah.
looks
Look at gas cooler.
even for the gas cooler. Okay, that's a pretty big one, but anyway. No, good to see you, and also good to see you in the new shirt and with the new logo. I just realized that the winter arrived. We are now getting our winter clothes here, and I think that's gonna help a lot. Okay, next to you, Jemsen, let me also introduce this colleague here. Actually, is not that far away, not some 1,000 kilometers, but only a few centimeters. Tobias, good morning. Good to have you here on board. I must admit I was a little bit not nervous, but the topic today is special. And so I'm happy to have you experts here on my side helping and supporting me in doing this because today's topic is probes, and not just only standard probes but special probes. And therefore I'm happy that we can start with the presentation already. So if we have a look at the agenda, and by the way, it was super nice to see that we had even again 300 people signing up. We are so thankful for this, even for such a special topic. This is just great and gives us a good chance and opportunity to really discuss this topic with you and inform you about our latest solutions, but also receiving your feedback about the solutions to find out what is the best way and where can we also improve. Our world team. What did you say in the preparation, Jemsen? This is not the.
I was calling them the three musketeers.
The three musketeers is super. That's true. That's a good say. I don't know if Jose is online. Jose is online. He already says hello from Dubai. Good to have you here. And we know that for the South American people or for the people in the US in general, the time zone is a little bit a problem. It's very, very early for them. Great to have everyone here. Let's get started and let us show you. You know, when I was setting up this webinar, I was thinking, can we do it in 30 minutes? And I thought, wow, this is so special topics. I think probably not. Let's see. I don't know if we really need like the 60 minutes. Maybe it goes a little faster and everything is great. But if it takes that long to describe the different situations, I think that's also fine. After having a very, let's say maybe intense time at the AGEMA and streaming even from the AGEMA, I'm very happy that we can return to our normal kind of schedule for the webinars. So first of all, we will have a short overview of what is coming up, what is the next webinars we are planning till the end of this year. And then we will start with an overview of the DNA, I call this, of PSG probes. I think something which is very important because all of these characteristics, all of these features, let's say, or most of these features are included in all of our probes. So this is kind of the basis, the base work. I do the base work and also the explanation about the double back purging solution we have with our PSG Plus solution there. And then we have ATEX as one of the special topics and DeNOx as another very special topic where I think we have great solutions to present. Okay, maybe just we start with the outlook here. At the 13th of October, we will talk about heated lines and tube bundles. What is special about this? I mean, we've been discussing heated lines in the other webinars already, but what we will do in this particular webinar, 13th of August, is we will see what is a tube bundle. So we will discuss this topic layer by layer. We start from a single tube. We will tell you what is important about single tubes in our industry, what is important about surface treatment in tubes, what kind of extrusion is possible, what kind of insulation is possible, what in the definitions are tube bundles, where are they used, where's the good solution for this, and and then at the very end we are going to let's say end up in the topic of heated lines. And gentlemen, I think it's important because what we will discuss there is not only for the process analytic, but also for the instrumentation. So I think it's important that we can invite many people to discuss this, because I think still when we had a very interesting conversation with people from Japan, and even there, some of the applications, they still use single tubes, heater, and insulation, manual, and not pre-configured. So something we are looking forward to this, to discuss this with you. Next one is special heated sample lines. This topic more is about, like I said, the topic of surface treatment on the one hand side, but we have been developing so many specialities in the field of heated sample lines that I think it's worth to spend one webinar to show what is additional functionalities, what is additional features we can add to these heated lines. And therefore we will talk about the hybrid solutions and topic of fully ATEX certified. Tobias, I'm looking into your direction, so pretty sure one of the topics which will be mainly with you. Okay, so and then then we are already at the 17th of November. We will recap. I think in the last session, Jemson, we called this the heart of the sample handling system, right?
Absolutely.
Yeah, so sample gas cooler, where we look at basic cooler for SEMS application, plus cooler for which can be equipped to a complete, let's say, yeah, conditioning system, not just for the sample gas cooling, and also the process cooler for ATEX areas. This is, yeah, the plan for at least till the end of November, and then yeah, let's see. Maybe we can find some more guests who will join us here. But yeah, I think that's a good outlook of what is going to happen until the end of the year. Very good. Okay. Yeah. Allow me and to give a very short introduction. What are we actually doing here at PSG, the Perfect Sample Gas Company? So today we are focusing on the sampling itself. And by the way, it's very nice to see all the comments here in the background. So it's good to see that there's many people joined us. Let me just shortly show here his greetings from Malaysia. We have, oh, this is our colleague, Jonas. So it's a great help for us, not just to see your hello, but also to see your questions regarding probe and regarding sampling. So when we have a look at the yeah, different components of a sample handling system, today we talk about yeah, the primary tapping point or sampling point. And Jensen, from your experience, why is the topic of today so relevant?
I think you see, sample probe is the only component that is really exposed to the process. All right, and
Okay.
the rest of the extractive systems is outside. It is so relatively important that we get it right, you know, where it is exposed to the process in many of the corrosion, in terms of the high dust, abrasion, without about the condensation, about the dew point. So probe is the first thing that we always talk about. And one more thing that many people has neglected, the fundamental of selecting the right probe. Yeah. So therefore, when it comes to my turn, I will elaborate as much as I have, you know, in so many years of experience later on.
Yeah. Okay. Yeah, that's very interesting that it takes some time. So we understood that from all the components, from the probe, from the heated line, from the conditioning, or from the cooler, the probe has a very special meaning. And what I would also like to do here is to give a basic, or let's say an introduction. We've been doing this when we introduced the new PSG, but to understand when are we talking about what kind of application, product categories. So we have, first of all, the field of basic. What does it mean? We decided, oh, there is Antonio, by the way, from Brazil. He really got up at that time. So I think now Jensen, the musketeer,
Yeah.
how you said that, all musketeers are here and are online.
Yes, yeah.
I
I'm
think
so glad that,
that's
you know, in the middle of the night or in middle of the early in the morning,
right.
very early in
Yeah.
the morning, to join
That's
us.
a strong commitment. Very good. Yeah, super nice. No, but let's go back to our, let's say, new product strategy and the new product category. So first of all, we have basic, and basic, for our understanding, is still, I mean, no doubt, high quality solutions, but the difference between plus and process is, for example, the individualization. That means there's a lot of more options which come with a plus product line or the process product line compared to the basic product line. So we were saying, when you have a standard component to choose, for example, in the emission monitoring systems, I mean, today we will be more or less talking about the plus and the process, that meaning the process monitoring applications. But the field of basic is something we would override as SAM, as standard, as some configurations, but still in the heart of the components. And I think the probes will be a pretty good example to show the inside is same, like with a plus line or a process line. But yeah, there's some options which will just not be available in the basic. For plus, we say, okay, this is more individualization possible, and process mainly the field of ATEX, very robust conditions. So this is a little bit, yeah, let's say the new PSG product strategy, which we want to share with you and which is also represented on our new website, to give you an understanding. Okay, slowly. Tobias, you're too fast, way too fast. This is the young, you know, the young ambition people. No. Let's start with the theory here, and let me give you a short introduction to really the DNA of PSG probes. So what I was saying is that one unique thing is the filter inside our probes, and except the mobile version of our probe, all product lines, the PSG Basic, the PSG Plus, the PSG Process, have the same inside. And I think it's pretty yeah, interesting to show also the dimension of this. So when we talk about an application here where we have a high dust load, I would say the first thing which is very important is the filter itself and the filter surface. So Tobias, maybe you can yeah, shortly let's do the theory first. I steal one of the filters here and I will show some comparison here. So Jameson, you can hear us okay again, right?
Yeah, it's good.
Okay, super. So yeah, this is the inside. This is, yeah, maybe the core of the DNA of the PSG probes, meaning the big filter surface. And especially about the applications we are discussing here today, which is high dust and ATEX and DeNOx. I think this is the secret, so to say, to have a very reliable, low maintenance solution. Because in all of the applications we are discussing today, maintenance is a big topic. And also, Jimson, I think that's what you said in your introduction, selecting the right or the wrong probe is already a topic of the filter itself. Or what do you think?
Yeah, I think not only the filter itself, there are some consideration in general, like the material of the filter element. Okay, and then there's the blowback that we have to consider, and the type of filter that we design, especially in some countries, they emphasize on back purge. Everything we talk is back purge because we can understand them. Nobody wants to go up or go to the field, all right, unnecessarily. So, you know, so the foundation of that, if there's a dust, they will say, hey, let's do a blowback. All right. So, and this is so important that the audience must understand that blowback is only a philosophy. It is not able to blow back if they understand that how the ceramic filter is constructed. Yeah, maybe I pass it back to you.
Yeah, no, that's true. And I mean, if we have the comparison here, this is another filter, not from us, but you can already see from the dimension what is the difference here. And another very big difference is we filter from the inside, from the outside to the inside. Yeah, sorry. So we offer, so to say, the maximum filter surface. For sure. I mean, the concept of let's say the competition was filtering from the inside to the outside. They say, okay, the advantage is that the dust is not coming into the filter housing itself because it will remain there. Understood, fair enough. And for, let's say, nearly dust-free applications, I think that's an acceptable solution. But especially when you have high dust, can you imagine how fast that goes, that a small filter without having what you said, Jimson, the different layer of the filter, what would happen there. So this is maybe one thing, the filter itself, I think this is part of the DNA. And then we go into the back purging itself. And now my young colleague, you can illustrate, we try to illustrate how the back purging in theory works. That means, so the first purge, it's a dual back purge. So the first purge will be from the inside to the outside. That means all the particles sitting at the surface of the filter will be removed. And then when we have the second purge, we will be sending these particles, which are then flying around in the filter chamber, we will send them back to the process. And this will be the second purge. This is the purge via the filter chamber. Okay, I think that's already a good overview. Then I think it's the same for the DeNOx probe, for the ATEX probe. All general maintenance, Tobias, is done without any tools. Right? I think this is also an important feature. And what we are describing here in this slide, we would like to show you in real and in the demo. So Jemson, you have to guide us if the audio is okay and if you can see us okay. Yeah. So Tobias, if you can move this one.
Yeah, it's good.
So you see we are not very short. So yeah. Hopefully, this is something you can see. It's okay, Jemson? You can see it?
Yeah. Yes.
Okay. Very good. Yeah. So first impression, this is the PSG Plus probe. So for us, next to the filter inside and the filter surface, which you just saw pretty much detailed. By the way, this is the basic probe, and in the basic probe, we have the same filter element available. So this is what I try to explain about our product categories and our different products. The filter itself will be the same. But we are not offering as many options in the basic probe compared to the plus probe. So here you only see a single back purging, and here we have a dual stage back purging. So let's go through it and let's explain why this is so efficient against high dust. First of all, one of the very important things is we have to make the purging of the instrument here as efficient as possible. And you might find other products in the market which have a back purging. You might even find probe solutions with a dual stage or with a double back purging. But what you're not going to find is this unique dimension of the tubing. That means we have a very big tubing here, and we have here big solenoid valves, the coax valves. So, and all of this allows, in addition to, if needed, an accumulator, and all of this allows to be super efficient in the purging itself. That means we have there's a PLC steering system which steering the sequence of the back purging. And as soon as the solenoid valves are open, there's a lot of air which is really purged into the filter chamber. And this will make this back purging and this cleaning or self-healing or whatever you want to call this very efficient. So I think this is in terms of high dust applications one of the big secrets. And I mean, there's different philosophies in the market, James, and you said that, for example, the Asian region prefer back purging. I think they know back purging because, yeah, sometimes we have applications we can easily operate without back purging due to the fact of this very big filter. And I think another topic we should discuss here is pre-filters. And sometimes in the RFQ, we also see that people are requesting pre-filter. This would be a filtration inside the process. And this is also something in many applications which we do not really need, right? Yeah. So our philosophy is more to have the cleaning and the collection of the dust here inside and handling this pretty good. There's also some accessories. Our experts, our sales experts can help you very good in this. This is, for example, a pressure reduction valve, which allows to reduce the pressure, which is which will happen through the heated sample line when there's a lot of purging. There's some measures you have to do in order to reduce the pressure on the heated sample lines. But this is different topics and something we can only briefly touch here in today's webinar. So, Tobias, Jensen, anything I have forgotten?
No,
so far?
Let me contribute by summarizing the important points that you have covered for the benefits of the audience. So many people think that a probe is the filtering of particles, and we know jolly well that when the filter gets dirty and we want to clean it, all right, this is the whole mentality generally. Right. So to overcome all these things, so the audience must take note that how can it be purged, right? Number one, the secret lies on the filter element. All right, if you look carefully, there is a multi-layer with a white outside and there is a different color inside because there are different porosity. Right, number one. Number two, it is filtering from outside to inside. Right, that expanded the surface area so that we can have a longer maintenance interval period. Right, and then when we come to back purging, to have an effective back purging, you look at the tank. All right, the tank is relatively close. All right, the whole thing is only about 30 centimeters. All right, so it's important that many system integrator, please take note that do not position your air tank far away. Number two, look at the solenoid valve when they open. All right, ensure that it has a big tubing, that is no pressure loss. This is very critical. All right, so this is another area of that. So when it comes to emission, perhaps you only need one back purge, back purging the filter. However, if you are talking about high dust in a cement plant, in calciner, in preheater, with very high dust of 10 grams to 50 grams per meter cube, you really need the second back purging. That means back purge in the filter, then followed by back purging at the chamber. Right? So, and last thing, we have just mentioned that when we do a back purge, we do not want the sample to be altered. So therefore, we do not want the back purge air to go introduced into the analyzer. What we have is actually a pressure reduction valve. All right, that is so when they have a high pressure of higher than 1.8 bar absolute, it automatically, this mechanical valve will shut. All right, they stop the air from going back to the analyzer. So it concentrated all the pressurized air and goes forward to the probe and flush it out into the process. Yeah. All right. Back to you.
No. I think that's a very good explanation. Okay, so Tobias, what we are going to do now, we change seats. Because now comes not my field of expertise. So you have to sit here and I go there. It would be great if you can give us a good introduction of these type of products.
Screen says I'm Jörg now.
Oh yeah.
Okay, guys. What you see here is our portfolio or our current portfolio in the field of ATEX probes. The most important thing on the slide number 1 is just the holding temperature. Depending on your application, we are working with 90 degree, 150 degree, or 180 degree holding temperature. The number of holding temperature is always considered for the lowest environment condition we are allowing to choose the probe. That means for the ATEX 90 degree, we are working at a minus degree of 20, and for the 150 and 180 degree, we are working at minus 40 degree. We are not considering that you can go higher with the probe depending on the environment condition. We tell you at this low environment condition, we can still guarantee you the holding temperature of the full probe with 90, 150 or 180. This is maybe a separation from the market. Next thing, when designing an ATEX probe, what comes into my mind is two things. First thing is you want to have it as easy as possible in your application. You just don't want to have a complicated product, or you just want to lose your mind into the product. And the second thing is making no compromises. And this is the attention to what you said in the beginning, why PSG said we are working with the same filter element, we are working with the same probe, because let's face it, what happens if you're still working in a SEMS measurement and the tapping point suddenly becomes a zone 2 or a zone 1 application from authority, from customer, whatever, and then you have an ATEX probe. As you are still in the field of a SEMS, but just as determined as a zone 2 or zone 1 application, you still want to have that options you are familiar from a SEMS application. You still want to have a back purge system, maybe a pressure reduction valve, maybe you want to have that the valves are already at the probe pre-assembled, stuff like that. You still want to have that. And that's the conclusion of why we say we are working with the same filtration element from the technical point where the gas comes in and filtration and goes out. But of course, all the heating elements need to be suitable for ATEX environment, and some things around are changed for just making this happen.
Yeah, Tobias, I think that's a important part you're touching on here. Because Jensen, you recently sold some ATEX probes. Maybe you can share. Whenever I talk to the customer in this field, they say, okay, for the operators really focus on reducing the maintenance times in these areas. That means if something is declared or defined as an ATEX zone, it's maybe really an illegal obligation. You have to reduce the time where people are in this area because it's not a safe area, like it says. So, and I think there we can use our strengths with having this big filter and having low maintenance. I think this is something which is a big advantage there. Jensen, would you agree? Is this something you also hear from your customer? Or?
Yeah. In fact, just a couple of the couple of units that we just received the order from Thailand was that what is the determinants of the order a couple of reasons. Number one is that they want IP65 enclosure because this is a process environment in petrochemicals. Number two is that as I know that as far as EX concerned, we want to limit the amount of exposure at the site. Therefore, it is so important to have a large filter. All right, this large filter enable the customers to have a much longer maintenance interval. Right. So, and lastly, I think we have very, very unique in such a way that we have ATEX 150 and 180. I think this is another area that we are very happy in terms of heated temperature.
Yeah.
Right.
Yeah, and I think I would agree, Jim. That's a great achievement from the Perfect Sample Gas team that we managed to develop such a good solution. And like Tobias already mentioned, let's say more like a side fact that we can even hold this temperature in so cold environments that really shows the background. So PSG Probe ATEX 90 was something we already had since longer time, but the newer development is really the ATEX 150 and 180 degree C probe. And maybe also something, Tobias, this is more your topic because of ATEX and limiter and self-regulating. Maybe you can explain a little bit about what is the advantage of choosing our solution there.
Yes, sure.
Except the big filter and the stuff we already touched.
I get your point. This counts for all our ATEX probes. For the 90 degree, the 150 degree, and the 180 degree. We are working in the field of ATEX with self-limiting heating cartridges. That means for the customer or for the installation company, there's no need for any external controller or something like that. There's no need for setting up limiter points and talking to the authorities if this is correct or if this is not correct, because they get a certification that they can operate this probe in a zone 1 and inside of the temperature class T3, which is basically the most restricted thing you will find in the industry when it comes to extracting a gas sample point. And this is surely a benefit. I mean, you don't need any external costs, you don't need any external installation things, and of course you don't have that argumentation against authorities to say what I'm doing is correct because I'm setting those points and stuff like that. You just have a certification that says, okay, I'm allowed to operate this inside. And this makes also, convincing a customer, I think, much more easy because I know those guys do a good job, but talking to authorities is never fun. Let's say it like that.
Yeah. Maybe Tobias, you can show shortly. Now I will carry the camera, Jimson, I hope.
Mm-hmm. Yeah. Perfect positioning.
Yeah, there we go. Oh, I have to hold still. This is not very easy for me.
Okay, this is our biggest enclosure with an IP protection class of 65, which is suitable for ATEX environment because of the reduced surface resistance, which is also certified. Inside of the probe, I don't know if we can show the inside that much good.
No, the cable is not long enough, but I think just the filter, Tobias, I think it would be nice proof that everyone sees. Yeah.
I mean, in the end, this is what also you said, and this is what I followed up with is we are working with the same filter element, the same size, and it's becoming even more important. I mean, in the SEMS field, you don't want to send out the guys more often than your contract says, but in the field of ATEX, it's really the point you just don't want to send your guys out of this. So lowering the maintenance is also part of safety. And the part of sending the guys out for maintenance would even become more important in the last field, which Jensen is introducing to us. But I don't want to, make the teasing for that.
Right, Tobias. Okay, so let's sit down again. Today is a little bit changing positions here. Oh, that was not the one I wanted to choose. Hold on, one second. Here we go. Okay, back to the presentation mode. Okay, very good. So Jensen, anything we have not touched yet for the ATEX probes? Anything you wanted to add? Anything we've forgotten?
I think Tobias has done a great job. I discover new things in the midst of this presentation.
Okay, who says that this webinar is only for new customers? Okay, but yeah, that's fine. Great. All right. So then, DeNOx. I don't think. You guys, go ahead.
Jensen, do you want to start?
Yeah, it's my pleasure. My pleasure. So nice. I'm presenting this from the real practical experience in this part of, Asia. I would say in Asia. Let's put it that in the past, many times we measure NOx, NOx, all right, only 1 point, just to have the reading. But today, the environment has changed. The environment has changed drastically that, every of the DeNOx, they go into control, all right, the control. Therefore, the response time, the accuracy is so critical, all right, to avoid ammonia slip, all right, of any ammonia slip that going downstream that may affect the downstream processes, right? Therefore, it is pretty important that I like to share from here. Let's go to the next slide. Yeah, so big questions about ammonia. Many people buy ammonia probes without understanding why they choose the ammonia probe. There are many suppliers, but as far as application is concerned, right, as a system integrator, as a stakeholder, we must understand a few things. All right, we know that the temperature, it is proportional to the NOx concentration, and we reduce the amount of NOx by injecting ammonia, right, catalyst. And then we have to overcome process temperature of above 330 degrees. Generally, it's 360 degrees. Why it is so high temperature? Because of the presence of SO3, the very high acid dew point of SO3. All right, that is a contributor to the ammonia sulfide, which is we call it in short, the ammonia salt. All right. So once in any event that you will bring it down to below the SO3 dew point, any ammonia slipped, all right, will cause salification. Last one is the dust. All right. As far as dust concerned, to us, it is really, really very simple. All right, very, very simple. So the whole presentation, the next 2 slides, is to tell you about crystallization. All right, how to avoid crystallization. Right. Next slide, please. So I mentioned earlier, all right, the acid dew point of SO3, it is pretty high as 270 degrees C. All right, this is why the process temperature is much higher than 270. All right, so in the event that there is ammonia slip, you can see that the measuring point is after the DeNOx. It's not before, it's after, because they want to trap the efficiency. They wanted to control, a cascaded control, how much ammonia is to be injected. All right, so in this process, should there be ammonia salt, all right, ammonia that coming out from or escape from the DeNOx SCR, that is the area that we wanted to be careful on all our sample probe, all right, all our sample probe, because there are many people who understand that there is a high dust, so they do a back purge. Okay, so it is very, very silly to do a back purge at the sample probe, because in any of the sample probe that you do a back purge, even though you have a very high temperature of instrument air, all right, or there is a tendency of cooling down. All right, so this is a photo that you see, the powder, all right, the kind of powder is not dust. In fact, it is ammonia sulfide. So over here, in this probe, it is a mistake that some customers has done. The photo was taken by me, and then we will see how we overcome all this in the next slide. So in this slide, is a very general configuration. Is to tell you that for coal-fired power plant, of course, there is another application. We talk about, natural gas. All right, so those are very, very clean. It's easy to overcome. But for coal-fired power plant, with a high amount of SO3, high amount of particles, high amount of water, and all these things that come into effect, that you don't want to buy the wrong sample probe, and you don't want to engage so much of your labor hours to attend to the probe. So it is so important that when you look at the probe, it is important that there are two filters. In this case, there's a in situ filter, all right? In in situ filters is exposed to the high process temperature of 360. So even though you do a back purge through a three-way valve, all right, the back purge air when enters into a process is already raised up above the SO3 dew point. So that is the area that you can consider. Another area that is very critical is that the sample probe filter. It is back to where we are mentioning that we have a very big sample filter, and this sample filter in the probe, we should avoid back purging. We should avoid back purging. All right. So because once you back purge, you cool down. You cool down if there is any ammonia slip. I mentioned again, it is not the ammonia. It is when there is a slip. If there is a slip, because after the process of SCR, and then you happen to do a back purge, and that is getting a clog at the filter almost immediately. So therefore, a large filter element can play a very vital role. All right, why vital role? So that in any event, if there's any mistake, you just simply remove the filter, very economical, ceramic filter, and replace it without removing the probe, without taking out the flanges, just remove the filter element. The last thing that is so important is about the ammonia trap, right, or the absorber, right? It is so important to have this absorber because we have to trap the ammonia sulfide because the heated line is only 180 degrees. What happens if we do not trap them? If we do not trap them, the 180 degrees, it is not hot enough to bring to contain any ammonia slip. It will actually contaminate your gas sampling system. Right over here, where the luxury is that there is a specially designed to trap any of this ammonia salt before it goes to the heated line and prevent any of this ammonia salt carry over to the downstream of the sampling system. Okay.
Wow. Okay, that's a big theory. Yeah. It sounds a little complicated, but Jimson, maybe it helps if we can switch to the real life example. Tobias, maybe you can get into position. Jimson, you don't have a demo like this, but I think we can both or together explain what we see here and what we have. So,
okay, this is an example of a DeNOx probe, but it's a fully configured DeNOx. So, why do I say this? Comes later. What you basically have is you have a filter element here shown without the insulation sleeve that is heated up to 350 degrees. What happens?
315.
315. What happens after the probe? You want to cool down the medium as fast as you can. So it goes into that distance and into the vessel. The vessel is filled with glass balls to maximize the surface and to maximize this effect. So all kind of, let's say, salts that appear when you drop down in the temperature will happen here. After the vessel, there's a big outlet with a peristaltic pump to get the stuff all out. From here, you can continue to a magnet valve and then continue to a heated sample line with a lower temperature. You don't need, Jemson explained this, because we have already sorted this thing out. Now, this probe is also with a back purge. It's not for the DeNOx application Jemson explained right here. It's a special application we used for a customer in a savage sludge application. And he was not facing the ammonia problem. He was just facing salt problems that come with temperature drop down. But he still had the high dust problems. And therefore, he said, I need something to lower my maintenance interval, no matter how low, but give me the best you can do, that the guys don't need to go out to the probe anymore. And that was a quite successful job we did. I think he said numbers that we lowered the maintenance interval by a factor of 8 and to the previous probe, and that is what he was concerning about. But just to say, Jemson is totally right. When it comes to a normal DeNOx application, the back purge system is not necessary. What you really want to have is, you want to have a hot probe. You don't want to build the ammonia salt inside the filter, you want to build it here and then extract it and go out with your measurement to do the rest of the components measurement. This is basically the task.
Okay, Jemson, anything to add from your side?
No, I think we have a combination of Tobias and I think we have touched all the important part. I think the audience might have a lot of questions, and we welcome them to contact to us.
Yes, yeah, I think if there is any questions, we know that this topic is very special. Yes, come to me here. Let's sit closer. Yeah. No, we know that this topic is very special, and there's different applications we are surfing and we have solutions for. Yeah, I think this webinar here was to give a brief overview just about the probe itself and the special application ATEX and DeNOx. So this time we really have some time left for any Q&A. Is there any Q&A, any questions out there? Not so many at the same time, maybe.
You know, there's a delay.
Oh, there is a delay. It might take some time. But maybe I have a question for the DeNOx probe or the DeNOx solution you showed, Tobias. I saw some glass, and when I combine now back purging, very efficient back purging with glass, is there any risk of crashing the glass, or
as long as you use
the back purging, actually
you're totally fine.
Sorry,
the vessel can withstand much more.
Okay.
Yeah. So we encourage that the back purging goes forward purging. We don't call it back purge. Forward purging right into the sinter filter or the pre-filter, we call it. All right, and that is made of stainless steel. Over there, we remove we only address the dust. All right, not the ammonia. We address the particles so that we don't have to remove the entire probe. That is the whole thing. Yeah.
Okay, understood. All right. Okay. Yeah, maybe this time we really managed to finish on time. I think it's one of the very rare moments, but you see 55 minutes. So 30 minutes would be a problem even for this topic. Guys, I thank you so much for your explanation. I thank the audience for viewing and looking this up. So there is one question, by the way. So, hi, if SOF will pass due to bad air quality, in that case, how I ensure the correct sampling? If SOV, Jimson, you have any?
Let me answer this.
Please.
Yeah. So the solenoid valve, I think the solenoid you're talking about SOV is referring to solenoid valve, right?
Okay,
right?
super.
So we depends on the application, whether there is a high CO, like in the cement plant, all right, or if it's in the stacks emission, we use air, all right, instead of N2. So the most important thing is the quality of air, which I think you are trying to ask, all right, the quality, the air quality, the instrument air quality has to be dust-free, water-free, and oil-free. Yeah, this is very important.
Yeah, that's a very good point, Jensen, because sometimes we just show the accumulator, which is in your background, and we have to admit that for some applications we really have to heat it. We heat the accumulator. Otherwise, a crucial part here is something. If you purge, let's say, cool air into the hot probe. And it's a big dimension of cool air, that could also drop the temperature in the probe, and that would also then result condensation when the acid dew point is reached, right? So this is something, So maybe there's one more question. I think we have another minutes to go. So Jemsen, what
I can't answer the oxidizer without first looking into the schematic flow diagram. Yeah,
right.
I welcome to contact us.
Mr. Kumar, we are very thankful for your questions. But the Jemsen will get in touch with you and look into your application and the requirement of your application quite in detail. And then I'm pretty sure we can see if this solution or if any adjustments to the solution could solve your need. Okay, guys, thank you so much. Again, it was a great pleasure. Thanks for your preparation work, and see you soon.
Take care.
Bye-bye. Bye-bye.
Bye-bye.